Hello and welcome to my video on further engineering mathematics data analysis. We'll be looking at basic data analysis techniques that we all need to do to pass this course. So the topics we'll be covering are plotting a graph, the line of regression, and creating an equation for the line of regression. So the data we'll be using will be presented to us in a similar fashion to this. We'll have a set value and we'll have a measured value. And it's presented to us in two rows and many columns of corresponding data, but it could also be switched and we could have two columns and many lines of data instead. Now here, the top row has been and should be my controlled value. So you can see a very regimented increase in my measurements. I'm taking a 5, a 10, a 15, a 20. So that's set. Now, the bottom row here are the results of the test at each of those controlled points, and they look a little bit more random. So these are the values we're going to plot on our graph. So for data like this, we need to show how the values change with our control value. And when we draw a graph to show that, we need to have a certain setup. Our set control value needs to be set along the x-axis at the bottom, and our measured results need to be coming up along the y-axis on the left, or sometimes in the center. You should title your graph to show whatever it's showing, and then you just plot the points with an X or a dot to show where that data point lies. This will give us a scatter graph like this one here, because sometimes the data is less similar to this than it would be. Some values could be miles out, but there should overall be a trend that you can see with the eye, and we can see that this is starting low and finishing high as we go along. So we want to set ourselves a line of regression, otherwise known as the line of best fit or a trend line. And that's the red line here. It's taking into account all the values that I've got, and it's running in what we can see is a very similar fashion to what the data is trying to show us overall. Now, the way that you would draw this by hand, line up your graph so you can look along the data points. Ideally, have a clear ruler so you can see the data on both sides of where you're going to draw the line, and just keep making little tweaks here and there until you're satisfied that what you're doing is the line that you're going to draw is essentially what the data is trying to show you, and then just draw that line on. So that line we've just drawn will have an equation, and when we have a line like above, we can see two key points. It's a straight line and it intersects the y-axis at a certain point. Now, because both these conditions are true, the equation of the line must have a certain form, which is y equals m times x plus c, where m is the gradient of the line and c is the intercept point of the line with the vertical axis. So we're going to try and figure out what m and c are, so we can put them into an equation and put some real numbers there. So to get the gradient, we need to select 2 points along the line, measure their y and x positions, and then calculate the difference in the y and x values. So for example, position 1, which is the higher value on the right, is 40 along and 50 up. And position 2, lower on the left, is 4.57 along and 6.67 up. My change in y then is 50 minus 6.67, which is 43.33. And my change in x is 40 minus 4.57, which is 35.43. Once I've got those two values, what I need to do is to divide the change in y by the change in x. So 43.33 divided by 35.43, which is just 1.22. Now, when we pick 2 points, we want to pick 2 points that are quite far apart on our data. And that just helps us get a more accurate value. So creating the equation, it's the C component. To get the y-intercept, we need to simply look at the graph and take the value from the axis where the line of regression touches it. So as you can see here, I've zoomed into the left corner of my graph. Here we can see that it's very close to the origin of the axis. And when we take a measurement, I get a y value, which is 0.845. That's just looking at my scale, and the physical distance between the 0 and where that red line touches the vertical axis. The final thing we need to do is put our variables together in a straight line equation. So y equals mx plus c. We had 1.22 for m, and we have 0.85 for c. So we have y equals 1.22x plus 0.85. And that's the solution to this problem. Thanks for watching. I hope this has helped. I will speak to you in the next video. Goodbye.